Good morning. We're here in the Space Station Flight Control Room, and all the activities are going well. The on-orbit crew is working in the afternoon activities, and one of the big activities, especially for Karen Nyberg, Luca Parmitano, and to some degree Chris Cassidy, has been some of the first runs as part of the Ocular Health study. So joining us to talk about that is Dr. Christian Otto. Thank you so much for joining us.
Thank you, Nicole.
He's with the United Space Research Association.
That's right.
And he's the principal investigator for this study and also the NASA lead scientist for the VIP, which I've already forgotten what that acronym stands for, if you can explain for us.
That's the visual impairment intracranial pressure risk.
So a lot going on in that area. A lot of our viewers and people who follow the human spaceflight program are aware that bone and muscle loss is a common issue, and we're working on lots of countermeasures for that. To some degree, radiation is something we're always watching, but there's a vision issue that's kind of a newer topic that we've been following. Can you tell us just a little bit about that issue and how that's come up?
Yeah, you're absolutely right, Nicole. The visual impairment intracranial pressure risk is one of NASA's newest spaceflight risks, and was actually only discovered in 2005 when a number of crew members, one crew member developed an eye problem. It was a minor problem, and it was felt that it was perhaps a one-off, but subsequently another U.S. crew member developed the same sort of problem, and so with two individuals, there was some question in terms of why this was happening, and so subsequent investigation found that this was an abnormality that hadn't been seen before, and since then several crew members, in fact we're actually up to 19 crew members now who fall within the visual impairment intracranial pressure classification. So we now have a fairly robust program in terms of monitoring and trying to characterize this newest risk.
So tell us a little bit about this study that's been developed to look at that and understand it more.
Yeah, so the visual impairment intracranial pressure risk really involves the cardiovascular system, the central nervous system or the brain, and the eye. And the eye is how it first manifested the symptoms that we've seen. So the prospective observational study of Ocular Health and ISS Crews is our first formal take at doing a study over the next few years on ISS crew members to document systematically their eye health. We are getting some indirect measures of the intracranial pressure, which we feel is also an issue here. Our hypothesis is that the intracranial pressure is actually elevated in flight due to the fluid shift in zero gravity. And so we have a number of tests that we're doing. Many of these tests are similar to what people might get either at their family physician's office or at the ophthalmologist. And for example, Karen Nyberg and Luca Parmitano, two crew members who are on orbit right now, a number of tests have been done this week. In particular, fundoscopy, which is like ophthalmoscopy. So when you go to the doctor's office, they look in the back of your eye. That's exactly what we're doing with the crew members to get a really good view at the back of the eye. And there's a particular area that we're interested in, which is the retina, where all the nerves are, the rods and cones, etc., that receive the light. And we've seen some abnormalities there. In addition to that, we're doing tonometry, which is measuring the pressure in the eye. So it's a small device that you tap the eye. The crew member receives anesthetic, so it numbs the eye just temporarily. And we're able to get a pressure on the eye as well. And there's certain diseases on Earth, such as glaucoma, that involve high pressures. And some of the data that MedOps has received so far shows that there isn't abnormally high or abnormally low intraocular pressure, but we are seeing, we'd like to know, does it drift down or drift up? So that's another thing that the Ocular Health study is trying to do, is to characterize what's happening to the eye over a 6-month increment. Yes, we do. So there's a video that looks at the VIP working hypothesis, and I think we can run that for you now. And so what the viewers hopefully are seeing is you've got a schematic of the vascular system in 1G, and this is normal fluid movement. Now when you go to the 0G environment, as we mentioned, there's that cephalad fluid shifter. The fluids move towards the head because gravity is no longer pulling that down towards the legs. And what you see is this shift of fluid towards the head causes essentially blood to pool to a degree in the head and in the brain, and this raises the intracranial pressure. And what's interesting, that pressure communicates with the back of the eye, and as you can see in the schematic here, that actually presses on the back of the eye, changes the characteristics of the eye. It changes the vision of the crew member. We've seen changes in vision in a very large number of crew members. And in fact, the ophthalmologists refer to this as a diopter change, or a change in the optical power, such that they don't see things as well near, but they retain their far vision. And in fact, one crew member has developed scotoma, which is it was a temporary blind spot. You can imagine the challenge of that when you're trying to read checklists and so on.
Absolutely. So it's definitely a serious issue and one that's being looked at. And these are the first crew members to be participating in this study. How long do you foresee this going on? It's going to be several crews, several years?
Yeah, we're very excited. In fact, Karen and Luca are the first crew members participating in the study. We've spent the past 2 years putting this study together. We are aiming for 12 crew members, and we've had 4 crew members sign up, so there's a lot of interest amongst the astronaut corps, as you can imagine. We've got international partner participation, so we expect the study to be running for the next 4 years as we collect the data. So we're very excited to see this data as it comes down and the various parameters, and get a better understanding of what's happening in space flight to the cardiovascular, the central nervous system, in the eye, so that we can develop countermeasures, because there's probably a dose response. So the longer that you're in flight, it's likely the worse this problem gets. And as you know, moving towards a 1-year mission, that's of great concern.
Absolutely, something that they want to have a good understanding for, especially before we do any longer missions. And my understanding is the runs today are just the first in, I think, a series of 6 for each of these tests.
Yeah, that's right. So with many of the tests, medical operations, they already do these tests. In fact, they do it 3 times in flight. So the Ocular Health study aims to increase the number of data takes, so approximately once per month or 6 times during a mission. So that'll give us a much more accurate picture of what's happening. We're also doing it pre-flight, and we're doing it post-flight. We've added 3 additional measures post-flight for 4 in total, which will allow us to follow the crew member for 1 year post-flight, because we're finding that they're not returning to normal as quickly as we would like, and in some cases there are abnormalities that are persisting for years.
And also the tonometry and the fundoscopy that they're doing today, that's only 2 of the different types of things. It seemed like as part of the study, there's actually a whole myriad of different types of exams that you're doing to collect the necessary
you're
data.
absolutely right. So those are the tests scheduled for today. Tomorrow, I believe, we'll be doing ocular ultrasound, and this is a very important test for us because it actually gives us some indirect sense for what's happening to intracranial pressure. So we don't get a number, but we see changes that are consistent with elevations in intracranial pressure. So the back of the eye gets flattened. We call that globe flattening. We see widening. There's something called the optic nerve sheath that widens as pressure goes up. And these are things that we measure with the ultrasound. So that's very important. We're also doing ultrasound of the heart and taking blood pressure, and what that gives us is something called compliance, or the elasticity of the blood vessels, because we think that crew members who have more elastic blood vessels are actually, they're more protected against the visual impairment intracranial pressure problem, whereas those with stiffer vessels, for example, crew members who have higher blood pressure, they have elevated blood cholesterol, elevated blood sugar, and so on, their vessels would be a little more stiff, and we're finding those individuals are more severely affected by VIP. So that's another measure that we're doing. We talked about tonometry. We have a new device that will be on station that we hope to add to the Ocular Health study. It's called ocular coherence tomography, which is a very high resolution ultrasound that looks at the retina, so really focuses in on that part of the back of the eye that we're very interested in.
Also, I wanted to ask, it sounds like for the runs today, the crew members are being supported by medical experts that are helping with any questions and monitoring all of this. What kind of team do you have that's supporting the activities today?
Yeah, as you know, it's always a significant number of individuals supporting efforts like this. So we have a very large team. ISSMP has helped organize this experiment for in-flight. As you know, there are a number of biomedical engineers supporting this, and we also have subject matter experts, so optometrists who are in observing while the tonometry and the other studies are being done. So they will sit in while these experiments are performed to ensure that the clinical exam is performed properly. The fundoscopy, for example, that's getting a picture of the back of the eye and the retina. We need to make sure that we've got the right portion of the eye, that it's in focus, that we've got the image of interest, and so that's why the subject matter experts are there. And of course, the biomedical engineers, they've got to know how to work these tests. And you know, for your viewers, there's a real science in terms of being able to direct individuals to, you know, capture these very clinical tests that, you know, usually expert MDs are normally acquiring. So NASA does an amazing job at that sort of thing.
I was just going to mention they probably had extensive pre-flight training on all of this as well.
Oh yes, yes. Many hundreds of hours go into training the BMEs, and they do a wonderful job in acquiring this data. And it's really thanks to the whole team's efforts that we can accomplish studies like this.
This is all really fascinating. You touched on a lot of different factors that you're looking at to help understand this issue, but I'm understanding there's some possible, you know, benefits for people on Earth as well. The primary focus, of course, is to resolve this for spaceflight, but there could be potential benefits for human beings with various vision issues as well.
Yeah, that's one of the great things about doing medical operations in spaceflight is that we're really pushing the envelope in terms of you know, our techniques, how we're using technology, because we're sort of limited. We don't have an MRI scanner on space station, et cetera. So we really have to utilize the tools that we have in a way that is not always done on Earth. But also with this new problem, we're gaining information that can be applied to diseases on Earth. I mentioned one earlier, glaucoma. So for example, by measuring the pressure in the eye, and we are hoping to have a means of measuring pressure in the brain on station at some point, it's that pressure difference across the retina that causes the problems that we're seeing. And that has tremendous benefits if we have a way of measuring those pressures to clinical problems here on Earth, for example, glaucoma. There's another problem of raised intracranial pressure called idiopathic intracranial hypertension. So, and that's very similar to what we're seeing in space, and developing techniques to image that. In fact, one of our experts is publishing guidelines that will be used terrestrially. So we're already seeing spin-offs in terms of the VIP problem and how that relates to benefits to clinical problems on Earth.
Well, again, this is all really fascinating. Thank you so much for sharing with us, you know, everything that's gone into this, and we'll be following along with this study, of course. And this is just another good example of the space station serving as a platform for learning more about spaceflight and helping us go further, and maybe helping people on Earth as well.
My
Thank you so
pleasure.
much.
Thanks, Nicole.
Really appreciate it. Again, that's Dr. Christian Otto, the principal investigator for the Ocular Health study, which is a primary activity for some of the crew members today and will be ongoing throughout the increment. Thank you.